Okay, let's talk a little bit more about conservative forces versus non-conservative forces. So we have the example of gravity. So if I do work on a ball and move it from point A to point B, I'm in this example I'd be gravity is negative, right? Because the force of gravity is pulling down on it, but it's going up. So we know that we kind of do work against gravity, and a way that we've been thinking about it is that gravity doesn't transfer energy to the ball transfers energy to gravity in some way. And because we've done negative work against gravity, we've gained potential energy. And that's because the change in potential energy is the negative of the work done by a conservative force. And gravity is an example of a conservative force. And we showed a spring example. So if I had a spring, and here I'll draw me standing on it. So I jump on it, I exert a force down on it, the spring will compress, but the spring's exerting a force up on me, right? So here, and I'll draw what happens when I've actually compressed it. So now we've also done work now on the spring, right? And you can say that the work done by the spring is negative, again, because that force of the spring is going up, but we're actually pushing it down, which means that the change of potential energy is positive. If we think about like a slingshot or something, I guess. Let me see if I can draw one of those. This is pretty bad. No, it's not too bad. Okay, we pulling back this way. So I'll pull it back this way. But we can tell that the elasticy part, right, is making it go the other way. So I'll get the force of slingshot. Right, so then in some way the work that the slingshot does is negative. So change in potential energy is positive. Right, so all three of these are examples of conservative forces. The gravity, the spring, and the kind of like elasticy rubber band type thing. Now again, if I compare those to friction, and I push a box, the force of friction will always oppose me. So here I would do the work of friction would be negative. But here's the key part. There's no change in potential energy because friction is not a conservative force. Now, how can we see that it's non-conservative? Well, the three things up here, right? So springs, gravity, and elasticy things. We all have some intuitive sense that now that I've kind of done this, now that those things have done negative work, right? So that means that I've lifted the ball up, or I've compressed a spring down, or I've stretched out a rubber band, that I'm about to get that energy back, right? If I have a ball and I put it on top of a rubber band, I'm like, rubber band, I want you to do some work on this ball, right? Doesn't want to do it. Nope. If I put something on a spring and I don't compress it, right? And I say, okay, spring, would you please like shoot this thing in the air? It'll say nope. And gravity, right? If I have a ball and I just have it on the ground, I say, gravity, could you like make this thing go really fast? It'd say nope. Right? And the only times that we can get these forces to really do something is when we kind of like wind them up, right? We need them to do negative work first. We need to transfer energy to them. So that means I have to do work against gravity in this first example. And then gravity's like, oh, okay. Now that you've kind of given me this chance, now the ball can fall. Or now this spring is compressed, now it can launch something. Now this rubber band is stretched, now it can launch something. These are conservative forces because when they do negative work, right, when we transfer energy to them, they will give us that energy back because now they have potential energy.